Okay, so let's begin with trigonometric graphs, and we'll be discussing sine, cos, and tan. And our maximum extent, let us start with sine theta, graph of sine, and it would be a sine bx plus c, where a, b, and c are constants, and x is the angle variable. So if we draw sine theta or sine x, it would look like this. Maximum value would be 1, minimum would be -1, so ranges from -1 to 1, and the graph ends at 360. If we are doing this in radians, this would be 2 pi and equal division pi. This is pi by 2, and this is 3 by 2 pi. Again, maximum is 1 and minimum is -1. So what happens when we draw 2 sine theta? So basically we are attempting for a. A is the amplitude. So when we draw the graph of sine theta from 0 to 360, this would be 2, -2, and nothing else changes. This is 360, and we have the equal divisions 90, 270, and 180 as shown. So this is about amplitude. Basically, the general graph of a sine theta would be where a is positive. This is 360. Maximum value is a, minimum value is -a. So what happens when the value becomes negative? For example, when you have -3 sine theta, a quick rough sketch, sine theta would look like this. This is 1, this is -1, but 3 sine theta will have 3 and -3. But what happens when it is negative? The graph reflects in x-axis. All those values which were positive now become negative. All those which were negative now become positive. So the graph will reflect in x-axis. Maximum value still stays 3 and minimum -3, and it still ends at 360. This is 180, this is 90, and this is 270. Now let's try to draw on one graph. Let's say we have this grid and we draw sine theta. If I say this is 1, this would be -1, and it ends at 360. And we draw 2 sine theta on the same graph. Only the amplitude changes, all other things remain same. So it reaches at a maximum value of 2 and minimum value of -2. This point is 2 and this is -2. So after we're done with A, let us now discuss B. It was A sine bx plus c. Now when we are discussing B, let me eliminate A and C for now, and we'll bring them back in later. Now B is basically number of cycles in 360. For example, if I say sine x, there is one curve in 360. When we say sine 2x, there will be 2 complete cycles in 360. So sine theta appears like this. It ends at 360, starts at 0, maximum is 1, minimum is -1. And sine 2 theta, I can say that this is 180 because we have 2 curves, 2 complete cycles in 360, and this value stays 1 and this is -1. Now bringing back A into the picture, let's say we draw 2 sine 2 theta. This first 2 says, or let me make it 12 to avoid confusion, this 12 says that it is the amplitude. An examiner tells you to draw the graph from 0 to 180 degrees. So we already know we have 2 cycles in 360. So one cycle will be completed in 180. So when we draw one cycle, this point right here is 180, starting point is 0, this is 90, this maximum value is 12 and the minimum value is minus 12. Let's have a comparison on one grid. Let's say we draw sine theta. So this ends at 360. Highest point is 1, lowest point is minus 1. Then let us draw sine 2 theta. Now this should complete in 180. And we have two curves in 360. Trying to make a better curve. I think the previous one was better. It should go to a maximum height of 1 and lowest of -1. And when we draw sine 3 theta, we have 3 curves in 360. 1, 2 and 3, all at 1 and -1. Bringing in C, A sine bx plus C. Now C is basically the shift. It takes the graph upwards or downwards depending upon the sign. So if we have sine theta, the graph appears like this, ends at 360 between 1 and -1. But if I say sine theta plus 1, I should take this graph 1 unit up. So all the points, when you raise them by 1 unit, this is what you get. So this new graph is sine theta plus 1. It is always easy to move the axis, the x-axis, then moving the graph. For example, we had this graph of sine theta. This is 1, this is 0, this is -1, and I tell you to draw the graph of sine theta -1. Now taking this graph downwards is a little tough. If you draw this downwards is a little tough, then actually moving this x-axis upwards. So if I just move the x-axis upwards, you can see that we still have the same labels, and we can remove this x-axis, and obviously when it was 0, 0, -1, you can change these. So this is sine theta -1. Now if we have a graph of 2 sine 3 theta plus 1, and the question says draw the graph from 0 to 120. As it is already 3 theta, we know that 360 by 3 is 120. So the cycle should complete in 120 degrees, and it is having an amplitude of 2 and plus 1. So I'm basically not mentioning any number on x-axis or y-axis. So just imagine that this is the line, this horizontal line. Just imagine. Do not draw it, and just imagine. So if we have sine theta, and because this is plus 1, this should have started from 0, and plus 1 makes it 1. This should have been -1, plus 1 makes it 0. And this is 2. And if we take care of this amplitude, we know that amplitude should have been plus 2 minus 2. Graph should be between plus 2 and minus 2. So only the amplitudes 2 and minus 2. So when you raise this by 1 unit, all the values actually go up by 1 unit, or we just bring this line down. And I start from 0. This is 1, this is 2, this is 3, this is minus 1. So graph will look like this. Then we have a question which says that state the range. For this particular question, I can say that the range is from 3 to minus 1. So let's say this is a function, and I can say this function ranges from minus 1 to 3. For instance, for sine theta, we knew that it was 1 and minus 1. So range of sine theta is minus 1 less than equal to sine theta is less than equal to 1. So for any graph, for example 7 sine theta, we know that it would be from plus 7 and minus 7. So range would be minus 7 less than equal to sine theta less than equal to positive 7. So what if the question is 17 sine theta plus 4? So we know it would have been 17 and minus 17. This plus 4 raises it by 4 units. So you just add 4 to them. 17 plus 4 is 21. Minus 17 plus 4 is negative 13. So we have the range from minus 13 to 21. Any confusion in cos theta, sine theta? Now all these things remain same for cos theta other than the shape. Shape of cos curve is like this. This is 360, 1 minus 1, 180. Everything else stays same. So I'm quickly drawing it. Let's say cos 2 theta. So we have two curves in 360, or I can just draw it till 180 and it is still cos 2 theta. So if I touch the amplitude 3 cos theta, this is the curve, ends at 360. Now this is 3, this is minus 3. If I write 3 cos of 2 theta and I am drawing one cycle, 2 theta means there are two curves in 360, so 180 makes one curve. This is 3, this is minus 3. And same goes with 3 cos theta plus 1. So I have to raise it by 1 unit. I'm just sketching the curve. I knew that I would have started from 0 and this highest point would have been 3. But because of this plus 1, this is now 4. This lowest point should have been minus 3. But because of this plus 1, this is minus 2. And this now becomes 0 and it ends at 360. So A, B and C for cos. Now let's try for tan theta. Before we draw the graph of tan theta, it is advised to make these 4 equal divisions and draw an imaginary line. It is not compulsory to draw, but it's better if you mark it. These are known as asymptotes. Graph will not touch this line. It comes here and raises, and it never touches this vertical line. This is 360 and we do not have anything on y-axis. So graph of tan theta, if I say this is graph of tan theta, that's true. If I say this is graph of 2 tan theta, that is again true. If I say this is graph of 713 tan theta, that's again true. So the amplitude in case of tan makes no difference. And for tan theta, let's say we introduce a number 3. So this should now contain these type of curves in 120, because in 360 there are 3 times, it makes 120. So what we do is we just draw these 4 points and an asymptote at second and third. We just draw the curves, and because we knew that it is 3 theta, it should end at 120. This is 120 degrees, and then use your calculator to mark equal divisions, and that's it. So this is true for tan 3 theta, or if you say that this is 7 tan 3 theta, that is again true, because in case of tan, amplitude does not matter. Third thing, let's say we have tan theta, first vertical line, second vertical line ends at 360, and we draw graph of tan theta, and then the examiner tells you to draw it for tan theta plus 1. Now moving these curves 1 unit up is a task. So moving the horizontal line, the x-axis, down by 1 unit is much easier. And if you just remove this and write 0 here and 1 here, now this is tan theta plus 1, graph of tan theta plus 1, this right here. So for example, if I have a question 7 tan 3 theta minus 2, so what I'll do is, because it is all with pencil, I'll quickly mark these 4 points, draw these dotted lines vertical, draw this sketch. Now this 7 doesn't matter anything to me. This 3 means it ends at 120, and this minus 2 means this graph should move 2 units downwards, or I should move the horizontal line 2 units upwards and remove this previous line. But I do need these markings. This 120 should be right here above the previous one, and this point is 60. This vertical line was 30, the second vertical line was 90, and because it is minus 2, the graph is moving down. This is 0, this is minus 2, and that's complete. Any confusion till now? So if we are drawing cos theta from minus 360 to 360, we already knew that cos theta would look like this. This is 360, but the examiner wants you to go in negative axis as well, so you draw a curve to left. And let's try this question. Now it says sketch the graph of cos theta for interval minus 180 to 180. We already know that this curve which ends at 360, this is a cos curve, but examiner wants to see it till 180. So what we will do, we will not draw this section, and till minus 180 we knew that it would be like this, but we'll not draw this section. So my final graph would be this one in green, which ends at minus 180, and on this side ends at 80. This is 0. This highest point is 1, because this is cos theta. Magnitude, the amplitude is 1, and this point is minus 1. Question number 4a. Cos 30 is equals to square root 3 by 2. Use your graph in question 1 to find another value of theta. So cos theta is equals to square root 3 by 2. Okay, we have this sketch, and cos 30 is 3 by 2. Now see, this is 180 right here. So this should be 90. and this should be 30 and 60. So if I have this 30 and this value is right here is square root 3 by 2. So when you draw this line, wherever this cuts the graph gives you the second value. So this is minus 30 from my graph. So either at cos 30 we have square root 3 by 2, or cos of minus 30 we have square root 3 by 2. Getting it? Now transforming trigonometric graphs. This is exactly what we covered. A sine bx plus c. A, how does that transform? This is the amplitude. Sine theta 1 minus 1. So what happens when this goes to? This is a vertical stretch with scale factor 2. What happens when c changes? This is again the transformation. We call it translation. For example, when we move from 2 sine x plus 1 to 2 sine x plus 7, what is actually happening? This graph is moving 6 units upwards, so we can say it is a translation of 0 6. So a is just a stretch, scale factor is right there, and c is translation when it is positive. There is no change in y, but there is a change in x-axis. B is number of cycles. For example, if we change it from sine x to sine 2x, this was completing in 360, this is completing in 180. So when it is 2, the graph is actually squeezing in, so I can say this is a scale factor of 1 by 2. Any confusion? Now there's one more thing we need to add, which is a sine bx plus d plus c. We added this d. So it was sine theta and now it is sine theta minus d. What does this do? This makes the graph move towards right or towards left. Sine theta is this graph, and when we have sine theta plus 30, this positive sign makes it move towards left. So this graph right here would move 30 degrees to left, and it is not easy for me to draw, so what I'm doing is to, instead of moving the graph 30 degrees to left, I bring this vertical line 30 degrees to right, and now change the labels. This is 0, this becomes minus 30, this was 360, now this became 330. Highest point is still 1, lowest point is still minus 1. And when we subtract this, for example, sine 30 theta minus 60, this would take the graph to right, and this is sine theta. On reverse side, this is sine theta. So without moving the graph, this minus means it is actually moving to right, so I'm taking this vertical line 60 degrees backwards, and this is my graph. This was 0, now this point is 0. This ending point was 360, but it has moved forward, so 360 plus 60 is now 420. This point is 60 degrees. Highest point is still 1, lowest point is still minus 1. So question 7 says the graph shows the curve y is equals to cos x plus 30. So this graph is actually moved 30 degrees towards left. From minus 360 to 360, graph is already drawn. Write down the coordinates of the point where the curve crosses the x-axis. So we knew that it would have crossed at 90, but now because of this plus 30 it has moved 30 degrees to left. So this is now 60. 270 and 30, when we take away 30 from 270, it is now 240. This was supposed to be minus 90 and it has moved 30 degrees backwards and it is now minus 120. And again from 270 it has moved back 30 degrees. This is now 300 degrees with a negative sign. B part says find the coordinates of the point where the curve crosses the y-axis. So it is crossing at this point. At that point, let us solve this. This is theta is 0. So when it crosses y-axis, we have coordinates 0 comma y. So I can substitute this 0 in x-axis in x, and we get y is equals to cos of 30. So when you punch in the value cos 30, make sure the calculator is in degrees mode, we get square root 30 by 2 or 0.866. Look at question number 8. The graph shows the curve with the equation y is equals to sine x plus k. Now we are not sure what k is, but we are sure that this is sine theta's graph. It should look like this. It should have been like this starting from origin. But what do we see? We see that it is crossing at 300. It should have been ended at 360. So this graph is moved towards left, and by how much? By 60 degrees. Can you see it? So you see it should have been at 0, but it is at minus 60. So the graph is moving 60 degrees to left. So value of k is 60 degrees. Second says, is there more than one possible answer to part A? Yes, there is. This is 60. It may have been moved 300 degrees to the other side. Are you getting it? If we move it from like this position to this position by 60 degrees, it is possible. But what if I just moved this entire graph 300 degrees to right? For example, this was the graph right here. If I move it 300 degrees to right, the previous curve would come right here. This point will come right here if I move it 300 degrees. Yes. Clear? Question number 9. The variation in depth of water in a rock pool can be modeled using the function y is equals to 30t. Whatever the question is, I'm just assuming that we should have one cycle in 12 degrees because of this 30, where t is the time in hours from 0 to 6. Sketch the function for the given interval. Okay. Now we know that height is 1 and minus 1, and if I draw this one cycle, it should have been ended in 12, but the examiner demands it to draw it in 6 only. So what I'll do is draw half curve. So this is 6, this is 1, and this is minus 1. Second part says if t is equal to 0 represents midday, during what time will the rock pool be at least half full? So 0 is midday and if half full is 0.5. So sine 30t is equals to 0.5 and 30t is equals to sine inverse of 0.5, that is 30. The t is equals to 1. So at t1 it is half full, and on the other side it should be, we have to find it in both angles, both the quadrants. So if this is 30, this is 30, and that will be 150. So at 5 hours and 1 hour. Question number 13. Sketch on the same set of x's for the interval 0 to 180 the graph of tan x minus 45. I need more writing space. So first is y is equals to tan x minus 45, and the other is y is equals to minus 2 cos x. So if we have to draw this on same grid, okay, so first vertical line, second vertical line, this is a rough sketch of tan x. Negative 45 means the graph is moving towards the right. So if the graph is moving towards right, I'm bringing this y-axis 45 degrees back. So once we do that, what happens? We add 45 to each point. The second point was, imagine this was like this point was 360, center was 180, this is 90, this was 0, this was 270. So what are we doing? We're adding 45 to every number. 90 plus 45 is now 135, 180 plus 45 is 225, 270 plus 45 is 315, and 360 plus 45 is 405. So we have our graph of tan x minus 45. So we remove these old indications and we have the new graph in red. So this is tan x minus 45. For y is equals to minus 2 cos x, we already know that this should look like this. Start at 2, least is this, and end at 360. So we just use this line. This is 2, this is minus 2, and right here somewhere we had 360, and on the opposite side this was the point which is 180. Thank you for this indication. This is negative 2, so it should be a reflection in x-axis. So these are the two graphs on same axis. Clear? And then it says deduce the number of solutions of the equation this and this in the interval 0 to 180. So number of solutions, we can see this was tan x minus 45, and then it had plus 2 cos x is equal to 0. So if you just take this on the other side, this is tan x minus 45 is equals to 2 minus 2 cos x. So where are these two equal? It is at one point. So they have one solution. So and we had to draw it from 0 to 180, right? So just till 180, if we draw it from 0 to 180, no solution, because we don't have any point of intersection. Question 14 says the diagram shows part of the graph y is equals to f of x. It crosses the x-axis at 120 and 0, B point is P0. It crosses the y-axis at 0q and has a maximum value at D. Given that f of x is equals to sine x plus k, where k is positive, write down the value of P. So we knew that it should have passed from 180, but it is 60 degrees backwards. So it should have ended at 360, but it is 60 degrees backwards. So P is 300 degrees. The coordinates of D. This highest point in neutral graph and sine theta, this highest point should have been x 90 and y1, but it has moved 60 degrees to left, so this is now 30 degrees and height is still 1. The smallest value of k, so smallest we have already discussed that, this is 60. Positive value because it said it is positive and the graph is moving towards left. And value of q, this q should have been right here, or we can just substitute 0 in the given equation. F of x is equals to sine x plus 60. Substitute 0. When x is 0, we can find q. So sine of 60. So sine 60 gives an answer of square root 3/2. Clear? Say that again. Okay. Question number 15. Consider the function f of x is equals to sine px. P is a real number from 0 to 360, the closest point to the origin that the graph of f of x crosses the x-axis has coordinates 36 degrees. So determine the value of P and sketch the graph of f of x. Okay, so this is sine px. If this would have been sine x, the graph will cross at 360 and 180, but it tells you that it is actually crossing at 36. So if the first value is crossing at 36, second must be crossing at 72. So 360 by 72, cycle should have been in 360, it is in 72 degrees. So 360 divided by 72 gives us 5. So you get the value of P, that is 5. And sketch the graph from 0 to 360. So determine and sketch this. So we have 5 cycles in 360. 1, 2, 3, 4, 5. Amplitude is 1, -1, and it ends at 360. Write down the period of f. It completes in 72 degrees. Question number 18. A series of sand dunes had a cross section which can be modeled using sine curve of the form sine 60x degrees, where x is the length of the series of dunes in meters. Draw the graph of sine 60x from 0 to 24. So 360 by 60, it ends in 60 degrees, 6 degrees. And we have to draw it from 0 to 24. So we should be drawing 4 cycles, 1, 2, 3, and 4 cycles, because it ends at 6. So this is 12, this is 18, this is 24. Height is 1 minus 1. B part says write down the number of sand dunes in this model. So we have 4 of these. Give one reason why this may not be a realistic model. Any guesses? Angles are too small and they may not have the perfect shape, they may not be similar to each other.